The command center. Less is exponentially more. I assume this is a talk about Go. I feel it. I feel this is about Go. By the way, my shaver broke, if you're wondering why I'm turning into a bearded man. I don't know what to do with my life, okay? I want to have a mustache, but I literally have no availability to have a mustache. Here is the text of a talk I gave at the Go SF meeting in June 2012. This is a personal talk. I do not speak for anyone else on the Go team here, although I want to acknowledge right up front that the team is what made and continues to make Go happen. I'd also like to thank the Go SF organizers for giving me the opportunity to talk to you. I was asked a few weeks ago, what was the biggest surprise you encountered rolling out Go? I knew the answers instantly. Although we expected C++ programmers to see Go was an alternative, instead, most Go programmers came from languages like Python and Ruby. Very few come from C++. Interesting. Their original goal was C++? Huh. I wouldn't have expected that. I actually thought it was Python. I genuinely thought Python was the target market they were going for, because Go has this like Python-esque feel to it, and it just feels like a natural transition. You know what I mean? Wrong. I literally would have never guessed that. All right. We, Ken, Robert, and myself were C++ programmers when we designed a new language to solve the problems that we thought needed to be solved for the kind of software we wrote. It seems almost paradoxical that other C++ programmers don't seem to care. This is hilarious. Really? This is so good. They wrote a language solving problems of the language they're used to, and then no one else agreed with them. Dude, hot take, that's because people who program C++ like to program C++. They're kind of like Rustlings, right? I don't think people that love Rust could go to another language, right? They're kind of like sucked into the Rust hole. And I feel like C++ is kind of that. You have to copium super hard to really love the language. Don't worry, I've copiumed hard myself, okay? And there comes a point where once you have that hammer and you're really good with the hammer, you can do anything. OCaml, by the way, is the greatest language ever created, even though I haven't done a lot. I actually have an opportunity to do some language server stuff for my job, maybe. And I want to explore what is the best language to write at. It'll probably end up being in Rust, but it would be really fun to consider Go or OCaml. The answer can be summarized like this. Do you think less is more or less is less? Here's a metaphor in the form of a true story. Bell Labs centers were originally assigned 3-letter numbers, 111 for physical research, 127 for computing research or computing science research, and so on. In the early 1980s, a memo came around announcing that all the understanding of research had grown, and it had become necessary to add another digit so we could better characterize our work. So our center became 1127. Ron Hardin joked, half seriously, that if we understood our world better, we could drop a digit and go down from 127 to just 27. Oh, that is super good. I like that. Of course, management didn't get the joke, nor were they expected to. Got him, stupid management. But I think there was wisdom in it. Less can be more. The better you understand, the pithier you can be. The pithier you can be. Keep that in mind. Okay. I like this. I love this philosophy, right? I actually really do like this philosophy. Back around September 2007, I was doing some minor but central work on an enormous Go C++ program, one you've all interacted with, and my compilations were taking about 45 minutes on our huge distributed compiler cluster. Shee! An announcement came around that there were going to be a talk presented by a couple of Google employees serving on the C++ standard committee. They were going to tell us on what was coming up with a 0 plus, yeah, right, as it was called at the time. It's now known as C++ 11. Oh, damn, this was pre-C++ 11? Ew. Well, I mean, obviously it's pre-C, but either way, before C++ 11, C++ was really just, I feel like at least you got like some smart pointers and stuff in there. But I guess they probably used Boost and they had all the things they ever needed. In the span of an hour at the talk, we heard something like 35 new features that were being planned. In fact, there were many more, but only 35 described in the talk. Some of the features were minor, of course, but the ones in the talk were at least significant enough to call out. Some were very subtle and hard to understand, like R-value references. Still don't understand it. The others were especially C++-like, like variadic templates, and some others that are just crazy, like user-defined literals. Classic C++. What does the world need? More features! features will continue until morale improves. That is literally it. I'm tweeting it. C++ Lang designer. Features will continue until morale improves. This feels like a good tweet. I feel like I could say it better, but we'll keep it there. You know, you don't want to overthink tweets, right? You just want to have the one that kind of comes into mind, right? Let's see. At this point, I asked myself a question. Did the C++ committee really believe that that was wrong with the C++ was that it didn't have enough features? This was almost 20 years ago. How funny. This article ages like a fine wine. Surely, in a variant of Ron Hardin's joke, it would be a greater achievement to simplify the language rather than add to it. Of course, that's ridiculous, but keep the idea in mind. Just a few months before that C++ talk, I had given a talk myself on which you can see on YouTube about a toy concurrent language I had built way back in the 1980s. That language was called Newsqueak. Oh, beautiful. And of course, it was a precursor to Go. I gave that talk because there were ideas in Newsqueak that I missed in my current work at Google, and I had been thinking about them again. I was convinced they would make it easier to write server code, and Google could really benefit from that. Now, I actually tried and failed to find a way to bring the ideas to C++. Really. It was too difficult to couple the concurrent operations with C++'s control structures, and in turn, that made it too hard to see the real advantages. Plus, C++ just made it all seem too cumbersome, although I admit I was never truly facile in the language, so I abandoned the idea. I mean, this is a cool idea, the fact that he tried to take these good ideas and then put it into C++ to try to make it like a, you know, instead of creating a new language, can you create a library or something that kind of fits the mold and does the right thing? I mean, I can appreciate that. But the C++ hex talk got me thinking again. The one thing that really bothered me, and I think Ken and Robert as well, was the new C++ memory model with atomic types. It just felt wrong to put such microscopically defined set of details into an already overburdened type system. It also seemed short-sighted, since it's likely that hardware will change significantly in the next decade, and it would be unwise to couple the language too tightly to today's hardware. Great foresight, by the way, right there. I really, like, this is such good wisdom when thinking about things, right? Like, I know this talk is damn near 12 years old at this point, or 11 years old almost on the dot, but it's shocking how wisdom remains unchanged, but ideas can change quite a bit. It's a beautiful thing. All right, anyways. We returned to our offices after the talk. I started another compilation, turned my chair around to face Robert, and started asking pointed questions. Before the compilation was done, we roped in Ken in and decided to do something. This sounds like every single time I've compiled a long compilation, I get sidetracked and I just get off, and oh man, the race begins, right? We did not want to be writing C++ forever. Don't blame you. I believe that's called purgatory. And me especially, wanted to have concurrency at my fingertips when writing Google code. We also wanted to address the problem of programming in the large head on, about which more later. Okay. We wrote on the whiteboard a bunch of stuff that we wanted. What is this word? I don't think I even know this word. Desiderata? Desiderata? What is this word? I don't even know it. Man, this guy is just things that are desired. It's about life. Okay, I never read this poem. Okay, well, note to self, read that letter. Desiderata. Desiderata. Wow, that's a hard word to say. I'm sure I'm missaying it, if you will. We thought big, ignoring details, syntax, and semantics, and focus on the big picture. That's good. I still have a fascinating mail thread from that week. Here are a couple excerpts. Robert, starting point, C. Fix some of the obvious flaws, remove CRUD, and add a few missing features. Okay. Rob, name Go. You can invent reasons for this name, but it has a nice properties. It's short, easy to type. Tools, Go C, Go L, Go A, and there's interactivity debugger interpreter. It could just be called Go. The suffix is Go. This is good. Robert, empty interfaces. Interfaces. These are implemented by all interfaces and thus could take the place of void star. I like this, but I think this is a failure of a complete enough type system. I really have never been a huge lover of the interface thing, the whole That's one thing that's always turned me off from Go. That's why I say I feel like typed unions have always just been something I really want, or tagged unions. It's something I've always really wanted, is just give me some tagged unions. Give me tagged unions in a basic way to manage memory in some sort of way other than GC, which they did with this whole arena idea. And you have like most of it kind of completed. Which is very, very exciting for me. And then just throw a little bit of syntax for handling errors based on the convention that's now there for 10 years. And you literally have a language that I think is just beautiful. We didn't figure it all out right away. For instance, it took us over a year to figure out arrays and slices, but a significant amount of the flavor of the language emerged in that first couple days. Notice that Robert said C was the starting point, not C++. I'm not certain, but I believe he meant C proper, because especially because Ken was there. But it's also true that, in the end, we didn't really start from C. We built from scratch, borrowing only minor things like operators and brace brackets and a few common keywords. And, of course, we borrowed the ideas from other languages we knew. In any case, I see now that we reacted to C++ by going back down to basics, breaking it all down and starting over. Isn't that pretty much what happened with C++ to begin with? They didn't like C, broke it down, made some changes. Boom, made a horrible language. You just did it again. We weren't trying to design a better C++ or even a better C. It was to be a better language overall for the kind of software we cared about. And in the end, of course, it came out quite different from either C or C++. More different even than many realized. I made a list of significant simplifications in Go over C and C++. Regular syntax. Don't need a symbol table to parse. Garbage collection only. Yep, no header files. This right here. Explicit dependencies, no circular dependencies, constants are just numbers. Int and int32 are distinct types. Beautiful. Letter case sets visibility. I hate this. This is, I really wish that one wasn't that. Methods for any type, no classes. Yeah, this is good, but I mean, in a sense, you kind of create classes this way. I mean, I like what they've done. I prefer the Go version of classes, if you will. I like this. No subtype inheritance. This is always just a good decision. Package level initialization as well-defined order of initialization. Isn't this largely considered a failure? Init. Any init functions are largely considered a failure. I'm pretty sure that's true. Files compiled together in a package. Package level globals presented in any order. No arithmetic conversions. Constants help. I always like just automated upscaling events, right? So if you do like a 32 plus a 64, it just goes to 64. That always seems like a reasonable cast up. Can we all agree with that one? It's like, I get why you'd never cast down or cast sideways to like a float, right? Like, I would never want a 32 to a float. I can see why you'd want to be explicit about that, just because you change the underlying binary representation. I'm on that team. And so then doing binary operations would then necessarily have to do what JavaScript does, which casts your number type, which is a 53-bit -1 amalgamation of dumb ideas, into a 32-bit signed integer for just that simple operation, right? So I can totally get why you'd want these things. Interfaces are, interfaces are implicit. No implements declaration. And what I mean by that, for those that don't understand what I'm saying right there, check this out. Sorry, I realize that no thing's like pretty specific. If I go like this, 130, you get this. If I go 131, you go negative, which is probably surprising to a lot of people. And if you go 132, you go all the way back down to 1, because there's actually an implicit casting. So if I go like this, 1, if I can I go even further? Look at that. Look at those fun things that can happen. You wouldn't expect a lot of these weird things to happen, right? And can we go like this and then or 0? Look how beautiful that is. Like, you can just get these weird results right on the end because you don't realize that there's a signed integer that's happening underneath the hood. And if you're doing anything in this region, it can be very surprising, right? And so the first time you encounter this, you're like, why is that happening? I don't get it. And it's because you're just getting hit with the 2's complement, right? You're just whoopsie daisies. You know what I mean? So, interfaces are implicit, no implements. Okay, I love that. Embedding, no promotion to superclass. Okay, methods are declared as functions, no special location. Methods are just functions. Yep. Interfaces are just methods, no data type. Methods matched by name only. Okay, I like it. I do like that because that means no type. I go back and forth on function overloading. Do I want overloading or do I not? I go back and forth because you either overload it by name, right? Then you have like foo with float, foo with this, foo with that. I never know. I never know if I like which one. No constructors or destructors. I can buy. Post increment and post decrement are statements, not expressions. Okay, nice. No pre-increment or pre-decrement. Assign is not an expression. Evaluation, order defined in assignment. Function calls. No sequence point. No pointer arithmetic. That's probably a good idea. No pointer arithmetic. Memory is always zeroed. I think this is always probably good. You should give an escape hatch for unsafe alloc, but this should always be the default. I think that this is just a safe, beautiful way not to F yourself, right? That's why I think Node actually did end up doing it right with their mistake of a buffer class, but that alloc unsafe, I think, was a really good move, right? I really do think that was one of the best design decisions by the Node team, though buffer being a mistake, right? Legal to take addresses from local variables. No this in methods. Yeah, but then you effectively recreate it by having a named version, and which is now just a single letter, and I don't know how I feel it. Segment and stacks, beautiful. No const or other type annotations. No templates, no exceptions, no templates, beautiful. But then they kind of went back on that with generics in 118. I like generics. I wish they had a little bit stronger generics, but I also feel every time I do a generic, I have to ask myself twice, am I really building the right thing? Because I have to be sure. Built-in string slice map, beautiful. Array bounce checking, beautiful. Those, like, these last two, this is just like, it's crazy if you don't have those, right? And yet, with that long list of simplifications and missing pieces, Go is, I believe, more expressive than C or C++. Less can be more. But you can't take out everything. You need building blocks such as an idea about how types behave, and syntax that works well in practice, and some ineffable thing that makes libraries interop well. They never even mentioned anything about errors as values, which I think is one of Go's greatest contributions, is errors as values. I mean, I already know is a thing, and there's other languages that did it, but Go is a very mainstream language, and for it to kind of bring that idea forward was beautiful. I just wish they would have thought of syntax, and I still wish they would consider syntax around it. We also had some things that were not in C or C++, like slices and maps, composite literals, expressions at the top level of the file, which is a huge thing that mostly goes unremarked, reflection, garbage collection, and so on. Concurrency, too, naturally. Concurrency, Go's concurrency model might be the best ever. One thing that is conspicuously absent, of course, is type hierarchy. Allow me to be rude about that for a minute. Please be. Early in the rollout of Go, I was told by someone that he could not imagine working a language without generic types. As I have reported elsewhere, I found that an odd remark. To be fair, he was probably saying in his own way that he really liked the STL does for him in C++. For that purpose of the argument, though, let's take his claim at face value. What it says is that he finds writing container lists of ints and maps of strings an unbearable burden. I find that an odd claim. I spend very little of my programming time struggling with those issues, even in languages without generic types. But more importantly, what it says is that types are the way to lift that burden. Types, not polymorphic functions or language primitives or helpers or other kinds, but types. That's the detail that sticks with me. Programmers who come from Go or come to Go from C++. This is a really interesting statement, by the way. I probably shouldn't have glossed over that so quick. It's a really interesting statement. Programmers who come to Go from C++ and Java miss the idea of programming with types, particularly inheritance and subclassing and all of that. Perhaps I'm a Philistine about types. What? I don't even get what that means. But I've never found that model particularly expressive. Yeah, the problem is that it's an extremely constrained way of being expressive, and it always ends up being just a burden. My late friend, is it Elaine? Elaine of Fournier once told me that he considered the lowest form of academic work to be taxonomy. Let's see. And you know what? Type hierarchies are just taxonomy. You need to decide what piece goes in what box. Every type's parent, whether A inherits from B or B from A, is a sortable array, an array that sorts, or a sorter represented by an array. If you believe that types address all design issues, you must make that decision. This is a very interesting argument because I almost feel like it's the antithesis to Rust's argument or Haskell's argument, right? Is this like a purely anti-Lisp rant? Code is data. Data is code. Very interesting. I don't know. I believe that's a preposterous way to think about programming. What matters isn't okay, yeah, he's specifically talking about that. Okay. Yeah, then I'm fully on that team. What matters isn't the ancestor relations between things, but what they can do for you. That, of course, is where interfaces come into Go, but they're part of a bigger picture, the true Go philosophy. And if C++ and Java are about type hierarchies and taxonomy of types, Go is about composition. Doug McLaury, the eventual inventor of Unix pipes, wrote in 1964, we should have some ways of coupling programs like garden hose, screw in another segment when it comes necessary, to massage the data in another way. This is the way of I.O. also. The man is way ahead of his time. Oh, is that an I? Oh, that is an I. McIlroy. Way ahead of his time. Beautiful. I love that. I thought it was 2 L's. That's why I was like McLaury. Okay, it's the primogen. Yeah. That way of Go. Let's see. That is the way of Go. Also, Go takes the idea and pushes it very far. It is a language of composition and coupling. The obvious example in the way interfaces give us the composition of components. It doesn't matter what the thing is. If it implements method M, I can just drop it in here. Quack. Another important example of how concurrency gives us the composition of independently executing computations. And there's even an unusual and very simple form of type composition, embedding. These compositional techniques are what give Go its flavor, which is profoundly different from the flavor of C++ or Java programs. You know what the surprising part about all this? He hasn't really talked a lot about concurrency. I think concurrency is their greatest feature of Go. Maybe it wasn't as big as like maybe the initial phases weren't so well thought out, but the asynchronous part is just so, like, there's so many things to love about it. And we read that Red Blue article not too long ago. I love the fact that Go is colorless. You don't have to handle a lot of these concepts like that. There's something about that is just so good. And I love that. I truly, truly love that. There's an unrelated aspect of Go's design I'd like to touch upon. Go is designed to help write big programs, written and maintained by big teams. There's this idea about programming in the large, and somehow C++ and Java own that domain. I believe that's just a historical accident, or perhaps an industry accident. But the widely held belief is that it has something to do with object-oriented design. Agreed. Thank you, Bob. Uncle Bob? I hate clean code. I don't buy that at all. Big software needs methodology, to be sure, but not nearly as much as it needs strong dependency management and clean interface abstraction and superb documentation tools, none of which is served by C++, although Java does noticeably better. Yeah, we don't know yet because not enough software has been written in Go, but I'm confident Go will turn out to be a superb language for programming in the large. Time will tell. We have huge programs at Netflix that are written in Go. They're very successful. They're very fast moving, and we get a lot of stuff done. Now, to come back to the surprising question that opened my talk, why does Go, a language designed from the ground up to do what C++ is used for, not attract more C++ programmers? This is what I want to hear. Jokes aside, I think it's because Go and C++ are profoundly different philosophically. C++ is about having it all there at your fingertips. I found this quote on C++ 11 frequently asked questions. The range of abstractions that C++ can express elegantly, flexibly, and at zero cost compared to handcrafted specialized code has greatly increased. That way of thinking just isn't the way Go operates. Zero cost isn't a goal, at least not zero CPU cost. Go's claim is that minimizing programming effort is more important consideration. Long as you're like 98%, I feel like that's fine, right? Go isn't all-encompassing. You don't get everything built in. You don't have precise control of every nuance of execution. For instance, you don't have Ray. Resource acquisition is initialization. Instead, you get garbage collector. You don't get a memory freeing function. By the way, they actually are going back on this potentially in 1.20. Did you see that? The whole arena allocations. I think that is a beautiful, like, not middle. It's not even a middle ground. It's like just one step from a collector saying, hey, you're still collecting, but I'm going to give you a handle that all the things go under so you can collect all at once. That is so Good. I really hope that they continue down this. What you're given is a set of powerful but easy to understand, easy to use building blocks from which you can assemble, compose a solution to your problem. It might not end up quite as fast or as sophisticated or as ideologically motivated as the solution you'd write in some of those other languages, but it's almost certainly be easier to write, easier to read, easier to understand, and easier to maintain, and maybe safer. To put it another way, oversimplifying, of course. Python and Ruby programmers come to go because they don't have to surrender much expressiveness but gain performance and get to play with concurrency. Yes. Yes. C++ programmers don't come to go because they have fought hard to gain exquisite control of their program domain and programming domain, and don't want to surrender any of it. Yep, that's what I thought. To them, software isn't just about getting the job done. It's about doing it a certain way. Bold claim, but I think I could buy it. The issue then is that Go success would contradict their worldview, and we should have realized that from the beginning. People who are excited about C++ 11's new features are not going to care about a language that has so much less, even if, in the end, it offers so much more. Thank you. This was an incredible talk. I cannot believe that a talk 11 years ago can still be so dang relevant today. You know, it's one of the things, it's one of these things that I've been kind of harping on a little bit about TypeScript, is that it's such an expressive type system. I find that you accrue technical debt really fast. And it's a hard technical debt. It's so expressive and so incredible that I have never had more problems with technical debt than I've had with TypeScript. Just saying. Maybe people don't like that. Maybe people hate that one. But I've just always had this problem where I think that there's this idea of just enough TypeScript. You know what I mean? TypeScript is too much for me. It's why I stick with Go. You need a million. Well, yeah. I mean, that's not really that's just an ecosystem. That's an ecosystem, right? Even if Node came with a singular tool that did everything, compilation, build, everything, it's all in a single step, I would still think TypeScript is too expressive. Even if there was no problem with building ever, I would still feel the same way. Yeah, I think OCaml's biggest problem is OCaml is functional. Functional is 100% harder to read for the average person. And I think that's probably just a starting point problem. But I also think that it might just be a procedural problem. Procedural is really easy to understand. It's just really easy to understand. So I think it's such a natural way people can express programming, and I think that's why it's such an easy way to start. But to be able to solve things recursively requires you to see things in a very vastly different way, almost counterintuitive. A lot like Vim. Like, Vim is counterintuitive, but in the end, it's better, I think. So can I believe that in the end, functional is better? Yes, I can. Do I believe it is just a no-go for starters? I think it is a no-go. Right? I think it is a no-go for starters. Sorry, Shirai. I think that it's a very, very hard thing to just start recursively. Recursive is one of the hardest ways to start thinking. Brian, when are you going to roast Reason ML? And said, when are you going to try Reason ML? I do want to try it. I do want to try it. Dude, I'm D to C. Okay? I'm D to C. The name is the Primogen.